Bardak nerede? Good morning. We are 7. May I see guys who are here now? I saw Damyan is here from Karposh. Christina is here. Angela is here. Monica, Vladimir. Miloshevsky. Easier to pronounce your surname. Sandra is here. Angela is from Karposh. Philip came. What to do? To wait a little bit more or to start? Let's start, guys. When they come, they will join us. Here is the first problem for today. Oh, spase. Finally. Welcome. First question. X squared minus kx minus 7 is equal to 0 and x squared minus 6x minus k plus 1 is equal to 0. These two equations, they have only one common root. We are supposed to find all the roots of these two equations. Like yesterday, you have time to read, to understand, to solve, to tell me the solutions of the question. At least to copy it down, you have 2 minutes. What to do in this question? What can we do, guys? We are given two equations and they have only one common root. Vieta, good. We can do Vieta. What to do? Sum of the roots, product of the roots of both. But there is a variable here, k plus 1. The coefficients of these equations are in terms of k. B is k, negative k in the first one, and c is negative k plus 1 in the second one. Yes, what have you got? What did you get from Vieta, Philip? In the morning, first question. I think we should give more time. Christina, Sandra, Monica, Damyan. Angela, Spase. Dimitar, is Dimitar here? Four equations with four variables. Okay. Good morning, Ariane. Welcome. Guys, what to do? Can we start to solve it? Did anyone get roots? At least the common root. No reaction. May I start to solve it? I hope you're all trying, that's why. Okay, okay. I'll wait a little bit. Is the common root 1? Yes, it is. It is. Bravo, Philip. Philip from Karposh almost solved the question. Let's do it like that. I will write your names for each question, who solved them, who solved at the end of the day, who solved most of the questions. I will bring Milka when I come to Republic, okay? I hope you'll all be in Republic. Yeah. Why didn't we do it yesterday? Okay, it's not late. Philip has first question, almost. Okay, what about the other roots? Christina, what did you get? You had 4 equations. Spase? Are you solving? Still writing? Good, next step, solving. Sandra? Guys, come on. 15 minutes for the first question. That's too much. Let's start. X squared minus kx minus 7 is equal to 0 and x squared minus 6x minus k plus 1 is equal to 0. I assume that the common root is a. So when I substitute a in the equations, we got that a squared minus ka minus 7 is equal to 0 and a squared minus 6a minus k plus 1 is equal to 0. When I check the coefficients of these two equations, 1 minus k minus 7, here we have minus 6 and look at these two. Minus k minus 6 and the constants of the equations, negative 7 and negative k, negative 1. Can I subtract these two equations to get a relation between a and k? Can we do that? Why not? If I subtract the equations, the difference will be 6 minus k times a is equal to 6 minus k. And when I factorize this, I will get a minus 1 times 6 minus k is equal to 0. Now, if we are given this equation, a minus 1 times 6 minus k, I need to check whether a is 1 or k is 6. What happens if k is equal to 6? Let's check the equation. If k is equal to 6, when I substitute the value of k here in the equations, we will get identical equations, right? If the equations are identical, what will happen, guys? They will have two common roots, but in the question it says that they have only one common root, which means that k cannot be 6. If k is not equal to 6, then a is equal to what? A is equal to 1. If a is equal to 1, then what will be k? How can I calculate k? If a is equal to 1, let's use the first equation. You substitute 1 squared minus 6 is minus 5. Minus 5 is equal to k plus 1, so k has to be negative 6. If k is equal to negative 6 now, let's write the equations. The equations will be x squared plus 6x minus 7 and x squared minus 6x plus 5 is equal to 0. And from here we can say that the common roots will be 1 and x2 is going to be negative 7 from the first one because the equation is 6x minus 7, x squared plus 6x minus 7. Here we have two roots, 1 and minus 7. And from the second equation, x squared minus 6x plus 5, we have roots 1 and 5. You see 1 is the common root, negative 7 and positive 5 are other roots of these two equations. Wait a second. Before I solve it, who solved? Christina solved it. Christina, there is a little mistake. 1, 7 and minus 1. Oppa. Any question? Is it clear, guys? Yeah, here is the solution. Is there any question? Clear? Strumitsa kids, Gevgelia kids, Radovish kid, is it clear? Do we have anyone from Tetovo today? No one. From Gostivar? Okay, I think we can show the next problem. Next question. Solve the equation a squared plus 2ab plus 2b squared is equal to 13 in the set of integers. Today we have many problems for the set of integers. Solve the equation in the set of integers. You also have two problems in Sigma 112. Solve the equation in the set of integers. This type of two questions you have in Sigma 112. What do we see here? On the left side of the equation we have a squared plus 2ab plus 2b squared. If you separate 2b squared as b squared and b squared, you will get a perfect square of a plus b. So the perfect square of a plus b and square of b is going to be 13. Then how to continue? Let me show you that step. Yep. I have explained up until here. Lotko says A and B both are 0. If both are 0, Lotko, can the sum be 13? The sum cannot be 13, right? A and B, if they are both 0, it doesn't satisfy the equation. Guys, here, since you have b in both terms, in the first term you have a plus b squared, and the second term is b squared. So better to focus on B. Philip, can B be 4? Can B be 4, Philip? Can you check it once again, please? Christina, what have you written? B is 2, B is minus 2. Yes, Christina, you got one of the solutions. But we have more. I mean, we have more cases to check. Are you giving values to A and B? Three and minus 3 are also solutions of B, says Monica. A is 1, B is 2. Yes, it is a solution of the problem. And A is minus 5, B is 2. The second one is correct, Christina. Bravo, Christina almost solved the question. So Christina's name is written for Milka. Angela says minus 1 and 3. Yes, Angela. Let's solve it, guys. Let's solve it. Let's assume that the absolute value of B is greater or equal to 0. If it's greater than or equal to 0, I told you, I will focus on B because B is in both terms. So I will write the equation A plus 4 to the power of 2 and 4 to the power of 2. This expression has to be greater than 16, right? It has to be greater than 16 because this is positive. It has to be greater than or equal to 0. And 4 squared is greater than 16. That means the sum has to be greater than 16, which can never be equal to 13. So if B is 4 or greater than 4, we will fail. If B cannot be greater than or equal, I mean the absolute value of B cannot be greater than or equal to 4, then the absolute value of B has to be smaller than or equal to 3. If B is smaller than equal to 3, what are possibilities? B can be, the absolute value of B can be 3, the absolute value of B can be 2, the absolute value of B can be 1, or the absolute value of B can be what? The last case, it can be 0. Let's check these cases now. If the absolute value of B is 3, then B is positive or negative 3. A plus minus 3 squared plus 3 squared is 13. So A plus minus 3 squared is equal to what? 4. So if A plus minus 3 squared is equal to 4, then A plus minus 3 is equal to 2. Right? 2 or minus 2, I'm sorry. 2 or minus 2. So A plus 3 is equal to A plus minus 3 is equal to 2, then A can be minus 1, minus 5, 1, and 5. So what are possible cases from the first one? A is minus 1 and B is 3. A is minus 5 and B is, wait a second, I'll write at the end all the ordered pairs. For the first one, if B is equal to the absolute value of B is equal to 3, then possible cases for A, minus 1, minus 5, 1 and 5. And then if the absolute value of B is equal to, if the absolute value of B is equal to 2, A plus minus 2 squared plus 2 squared is equal to 13. So A plus minus 2 squared is going to be 9. What do we have from here? A plus minus 2 can be 3 or minus 3, which means that A will be 1, minus 5, or 5. So if the absolute value of B is 2, A is 1 of 1, negative 1, negative 5, or 5. And the third case, if the absolute value of B is equal to 1, then A plus minus 2 squared is equal to 12. Since we are solving the problem in the set of integers, 12 is not a perfect square, which means that A plus minus 2 cannot be an integer. There won't be any solution. I didn't even check the absolute value of B is equal to 0 because it's obvious that 13 is not a perfect square. So how many possibilities do we have? 4 cases from the first, 4 cases from the second, so there are 8 different solutions for the given problem in the set of integers. Let me show the solution from the beginning. So for this question, I have written Christina's name. I haven't checked all the messages, but I think she got all cases. Minus 3, 3. Therefore, what? How, where? Who asked it? Why is it A plus 2 in the last case? Oh, it's my mistake. It's my mistake, Daryan. It's my mistake. Let me change it. It should be 1. But anyway, A plus minus 1 squared is 12. It doesn't have a solution in the set of integers. Spasse solved it in a different way. Did you get the same solution, Spasse? Good. Good. I think it's enough, right? Is it clear, guys? Can I show you the next problem? Okay. I don't remember from which sigma, but this is from this year's sigmas, from 110 or 111 or 112. One of x squared or 1 minus x squared is larger than 1 and the other one is smaller than 1. Prove that x squared minus x is between 0 and 2. 1 is greater than 1 is smaller than 1, you are supposed to prove that x squared minus x is between 0 and 2. How to start? Two cases, yes, we have two cases. These are the cases, right? X squared is smaller than 1, or 1 minus x squared is smaller than 1. If x squared is smaller, then 1 minus x to the power of 2 is going to be greater. If 1 minus x squared is smaller than 1, then x squared is going to be greater than 1. Remember solving inequality problems. To simplify this inequality, to get something useful, you can subtract 1 from each side. In both inequalities, you can subtract 1 from each side. I mean x squared minus 1, 1 minus 1, and 1 minus x to the power of 2 minus 1. And from here, 1 minus x squared minus 1, 0, x squared minus 1. So if we do that, we will get this expression. Which one? The first step. What did we do first? We said there are two possibilities. What are they? X squared is smaller than 1 and 1 minus x squared is greater than 1. Or 1 minus x squared is smaller than 1 and x squared is greater than 1. In these two inequalities, we subtract 1 to get 0 in the middle. To get 0 in the middle, I will subtract 1 from each side. So the first one is going to be x squared minus 1. 1 minus 1 is equal to 0. And 1 minus x squared, if you expand this binomial, it will be 1 minus 2x plus x squared. When you subtract 1, you will get only x squared minus 2x. And by the same way, if we subtract 1, we will get on the left side x squared minus 2x, 0, and x squared minus 1. So what can we say from these two cases? We have two cases. One is correct. X squared minus 1 is smaller than 0, or x squared minus 2x is smaller than 0. What's the conclusion from these two inequalities, guys? What can we say? We don't know which is greater, but we are sure that x squared minus 1 and x squared minus 2x are opposite, right? If they're opposite, what can we say about the product of them? So the product of them has to be smaller than 0. Any problem up until here? Any problem, guys? First part of the problem is very important. Any problem up until here? Damyan, is it clear now? Okay. Damyan asked the question. Yes, okay. Then what to do? What are we supposed to prove, guys? We are supposed to prove that x squared minus x is between 0 and 2. So somehow I have to get x squared minus x. I mean, I will try to write this inequality in terms of x squared minus x, because I must prove this inequality is true. Now, let me write the last inequality in terms of x squared minus x. How to write the first one? Can we write x squared minus 1 as x squared minus x plus x minus 1. Look at here. For the first factor, can we do this? Yes, why not? X squared minus x plus x minus 1 is the same. And the second factor, how can I write it in terms of x squared minus x? Here I have x squared minus 2x. It's much easier. X squared minus x minus x. So we got the inequality in terms of x squared minus x. Now we have product of two binomials. Let's multiply them. First by first, first by second, second by first, second by second. If we do the multiplication, we will get this. X squared minus x to the power of 2, first times first, x squared minus x to the power of 2, first times second, it will be negative x times x squared minus x. And the second one from the first binomial and the first one from the second, x minus 1 times x squared minus x, and second by second, it will be minus x times x minus 1 is smaller than 0. Now, here we have common factors, right? In the second and third terms, we have common factors. In both, we have x to the power of 2 minus x. Let's group them. I copied the first one, x squared minus x to the power of 2. And from the second and third, the common factor is x squared minus x out of the brackets. Now in brackets, we have from the first one, by the way, I have written here minus x squared minus x. So from the first one, x left. And is this term negative? No. So I must multiply x minus 1 by minus, because here I took negative x squared minus x before the bracket. So this will be minus x plus 1. And the last one is going to be, if we multiply them, minus x squared and minus x. Any problem up until here, guys? Just factorization here, nothing else. X squared minus x, and look at the middle term here, the one that I grouped. X minus x, we can deduct them. What left? 1, which means that the middle term is just x squared minus x. So we got this. X squared minus x to the power of 2 minus x squared minus x squared minus x. So the simplest form of this this inequality is going to be x squared minus x to the power of 2 minus 2 times x squared minus x is smaller than 0. Now can we use a variable here? We have common terms, x squared minus x squared minus x. Can we use a, k, t, whatever, any variable here? Yes, we can. First, I have written it in this form, x squared minus x. If I factorize, x squared minus x times x squared minus x minus 2 is smaller than 0. If I assume that x squared minus x is equal to t, then we can write the inequality in that form. T times t minus 2 is smaller than 0. If t times t minus 2 is smaller than 0, then Lotko wrote something. Let me finish, then I will check what you wrote, Lotko. T times t minus 2 is smaller than 0. If we solve the inequality by the help of sign chart, 0 and 2 are the zeros. So if you pick any number greater than 2, it will be positive, positive, negative, positive. The inequality says it has to be smaller than 0, which means that we have to shade the middle part. That means t is between 0 and 2. If t is between 0 and 2, what was t? T is x squared minus x. So x squared minus x is between 0 and 2. Let me show it from the beginning. Any problem, guys? Is this the expression that we are supposed to prove? Yeah, that's it. So we proved it. We proved that x squared minus x is between 0 and 2. Now I will check what Lotko said. You can divide by x squared minus x, since x factorial. Vlatko, if you mean this here in this step, in that step, if you think that we can divide both sides by x squared minus x to the power of 2, we may fail here because we don't know whether x squared minus x, what do we have, what are the roots from x squared minus x? X is 1 or x is 0? What if it is a root of the inequality? Yeah, maybe it is 1 or maybe it is 0. So not to fail, do not divide. Use a helping variable to reduce it to a quadratic inequality. Is it clear, guys? Is there any question? Do you want me to resolve it? Or let's explain from the beginning to make it clear. Once again, we said that at the beginning, there are two cases. X squared is smaller than 1 and 1 minus x squared is greater than 1, or the opposite. And if we subtract 1 from each side of the inequalities, x squared minus 1 is smaller than 0, x squared minus 2x is greater than 0, or the opposite. Then from here we got that, we saw that in both cases the product of x squared minus 1 and x squared minus 2x has to be smaller than 0. Then here, up until here, look, in this part, I just tried to write x squared minus 1 times x squared minus 2x in terms of x squared minus x, because I need to prove this expression. So after a couple of steps, after the factorizations, grouping, simplifying, then we got this. X squared minus x to the power of 2 minus 2 times x squared minus x is smaller than 0. We have seen that this can be written as a quadratic inequality. So I have assumed that x squared minus x is equal to t. So t times t minus 2 is smaller than 0, which means that t is between 0 and 2 by the help of sign chart. If t is between 0 and 2, then x squared minus x is between 0 and 2. And the proof is done. If there is no any question, I will show another problem. Yeah, most of you wrote clear. Only 2. Guys, can I skip this? Can I show you a new problem? Yes, Giovanna, welcome. Okay, let's see the next one. This is a nice problem. A, B, C are positive constants such that the equation c squared plus c squared x squared plus a squared minus b squared minus c squared times x plus b squared is equal to 0. This equation has no real roots. Prove that 3 segments with the lengths a, b, c can form a triangle. Is this a problem from Sigma? Are you asking about the fourth one? To be honest, I do not remember. If I had sigmas, I would check it now, but I do not have them here. I have the digital forms, so I cannot check. After the lesson, we can check whether it's from sigma or not. A, B, C are positive constants, and the equation is given. This equation has no real roots, And we are supposed to prove that we can form a triangle with the line segments A, B, C. What to do? What can we do for the first? Wait a second. No, okay. C squared x squared a squared minus b squared minus c squared x plus b squared. This equation has no real roots, which means that delta of this equation will be smaller than 0. We can start with this, right? Yeah, we have to prove this. This is the triangle inequality. A is smaller than b plus c, c is smaller than b plus a, and b is smaller than a plus c. When we prove that, we will be done with the proof. But how to show, how to prove that the triangle inequality holds. Yeah, let's find delta. Can you please find me delta, guys? In terms of A, B, and C, can you please find me delta? Is delta difference of two squares, guys? Yep, that is delta. Is delta difference of two squares? Yes. So factorize it, please. Yes, delta has to be smaller than 0 because it says no real roots. Christine, I got something. Let's see. Most of you got delta, I think. The equation has no real roots, which means that delta is smaller than 0. So we have this. A squared minus b squared minus c squared squared, which is b squared, minus 4b squared c squared is smaller than 0. Philip solved it. Philip, what did you get? Did you get the triangle inequality? A plus B is greater than C, B plus C is greater than A, and A plus C is greater than B. Okay. Anyone else? Philip has one more question from today. Philip did. Christina, I think you also got some inequalities. I couldn't check all, but did you get A plus B? I mean, did you get the triangle inequality? Yeah, you got one of them. You got them, Latko? Okay, let's continue. We saw that A squared minus B squared minus C squared minus 4B squared C squared 2 squares, so we can factorize it like first minus second, first plus second, which is A squared minus B squared minus C squared minus 2BC times A squared minus B squared minus C squared plus 2BC. From here, look at the last three terms, minus B squared minus C squared minus 2BC. Can we write this as minus square of the binomial B plus C and A squared minus square of the binomial B minus C? Can we write this? Of course we can. And here we know that A, B, C are positive integers. If A, B, C are positive integers, which will be greater, guys? Which will be greater? B plus C, the sum of B plus C will be greater than B minus C. So the perfect squares also will be greater. B plus C squared will be greater than B minus C squared, which means that the first one is going to be smaller than the second one. So A squared minus B plus C squared is smaller than A squared minus B minus C squared. Why? Because A, B, C, because A, B, and C are positive integers. They are all greater than 0. Okay, now what can we do? If we subtract A squared from both sides, up. Oh, wait a second, before that. This was product, so if A squared minus B plus C squared is smaller than A squared minus B minus C squared, since the product is negative number, one will be smaller than 0, one will be greater than 0. So if the smaller one is given, that will be smaller than 0, and the right side of the inequality is going to be greater than 0. If A squared minus B plus C squared is smaller than 0, then we can say that A squared is smaller than B plus C squared, which means that A is smaller than B plus C. We got the first one for the triangle inequality. And if I solve the second inequality, A squared is A squared is, wait a second, did I change it? A squared B minus C squared. I think I changed the sign here. B minus C squared. So A is smaller than B minus C. Yeah. A is smaller than B minus C, or A is smaller than C minus B. When you take root of both sides. There are two cases. And from second and third, from the first one, we got A is smaller than B plus C. From the second one, we can get that A plus C. Yeah, I have made a mistake with the sign. And 0, which means that A squared is greater than B minus C squared, which means that A is greater than B minus C, or A is greater than C minus B. Guys, I couldn't catch. What have you written? Damian, isn't it clear? Guys, where is the problem? What happened? Why are you 6? It has stopped. Okay. Is it better now? Any problem with the connection? Do we have any problem now? Okay. Okay. I'm waiting. If you're copying, if you're trying to get it better. Have you copied it, guys? Can I show you a new problem? You said it stopped, so I don't know how long did it stop. That's why I'm waiting a little bit more. Monica, Sandra, Aryan, is it clear? Angela, Lotko, I'm checking names. Guys, did it stop again? Woohoo! I'm changing the question then. New problem. P and Q are two integers and the roots of the equation x squared minus p squared plus 11 over 9 times x plus 15 over 4 times p plus q and 16 is equal to 0. Find, oh sorry, two integers and I've copied, while I'm copying the question I have made a mistake. P and Q are integers and the roots of the equation, we don't need this part again. Find the values of P and Q. So the variables are written in terms of P and Q, and also P and Q are roots of the equation. So if P and Q are roots of the equation, what can we see first? We can use Vieta, right? If P and Q are roots of the equation, we can use Vieta, and then we will find the relation between P and Q and then solve it. By the way, Strumitsa kids, I have solved you this problem in our Olympiad lesson, so please, I want you to solve it before me now. Same problem, we solved it in our Olympiad lessons. Yes, guys, please use Vieta. Write sum and product of the roots in terms of P and Q. And it's important, P and Q are integers. So the question will be solved in the set of integers. What did we get when we write sum and product of the roots in terms of P and Q? We got a system, right? P plus Q is P squared plus 11 over 9, and P times Q is equal to 15 over 4, P plus Q times plus 16. Spasia, Sandra, Monica, Dimitar, do you remember this problem? Do you remember how to continue? Are you trying to solve or should I start to explain? Do you have any idea how to continue, guys? We know that, okay, we can see that P and Q are integers, and if you check the first one, P squared plus 11 over 9, P squared over 9 has to be greater than 0, and 11 over 9 is greater than 0, so the first one, the sum of roots must be greater than 0, right? The first one has to be greater than 0. If the first one is greater than 0, then the second one. Look, 16 is greater than 0. P plus Q is greater than 0. So the right side of the equation is greater than 0, which means that P times Q must be greater than 0. Then, let's continue together. From A, I have written here. From A, we know that P plus Q is greater than 0 and P times Q is greater than 0 from B. If we multiply both sides, why did I choose B? Why didn't I work with A? Look, guys, here in B, I have first power of P, first power of Q, and P times Q. But in A, we have P squared, P plus Q. It's much easier to work with B. So let's multiply both sides of the equation by 16. Then I will get rid of this 4 and we will factorize the second one. If I multiply both sides of the equation by 16, we will get 16p times q. And if I take the first term on the right side to the other side, we will get 60 times p plus q is equal to 16 squared. Look at the left side of the equation. 16pq minus 60 times p plus q. How can I factorize this? When I factorize, if there are two binomials, when I multiply, in one there should be p, in the other one there should be q, because here we have the sum of p and q, and we have product of p and q. So can I factorize it by this way? 4p minus 15 and 4q minus 15. Let me check what do we get when I multiply them. 4p times 4q is 16p times q. Negative 15 times 4q and negative 15 times 4p gives me this. Negative 60 times p plus q. And when I multiply negative 15 by negative 15, I get 225, which is 15 squared. Do we have a 15 squared here? No. If I add it to the left side of the equation, I have to add it to the right side of the equation. So the expression is like this. 4p minus 15 times 4q minus 15 is equal to 16 squared and 15 squared. And 16 squared plus 15 squared gives me 481. What do we have here? Product of two factors is 481. Let me check factors of 481. Is it a prime number? No, it is not, but it is the product of two primes. So 1 times 481 gives me 481, or 13 times 37 gives me 481. Since I'm supposed to solve the problem in the set of integers, I also have to check the negative roots. Negative 1, negative 481, and negative 13, negative 37. So what are possible cases for 4p minus 15 and 4q minus 15? One and 481, 481 and 1, 13 and 37, 37 and 13. Why didn't we write the... Wait a second. Why didn't we write the negative cases? Negative 1, negative 48, 481. Wait a second. Do we get any solution if we write the negative cases? Negative 1 and negative 481. Guys, I forgot to check the negative cases, so you can check. After we finish, you can check them. Or we can check it here. If the ordered pair 4p minus 15 and 4q minus 15 solutions 1 and 481, 481 and 1, 13, 37, 37 and 13. The ordered P and Q 424, 124, 4, 7, 13 and 13, 7. When I check them all, only 13 and 7 satisfies the equation. I mean the system here. When you check them in the new system, the one we get from Vieta, when you substitute them, only 13 and 7 will satisfy the system. So the equation becomes x squared minus 20x plus 91 is equal to 0. And the solutions of the system will be 13 and 7, as you see. When you substitute in the equation 13 and 7, you will get solution. I have written x, but this is like p and q, right? P and q. P is 13 and q is 7. Any problem? Yeah, that part can be homework. I don't know why did I skip, but I didn't check the negative cases. You can check and see whether we have solution from the negative cases or not. I have checked it just for 148, 1 and 40, 481, 481 and 1. Yeah, I didn't check the negative cases. So I want you to check the negative factors. Is it clear, guys? Is it clear? Question? Or can you please write who got it? Nice, most of you got it. The factorization. I think this part, right? So what did we do? We multiplied both sides of the equation b by 16. So I got 16pq minus 60. When I take this to the left side, minus 60 times p plus q is equal to 16 squared. So I have to factorize, and somehow when I multiply the factors, I should get 16p times q. So can I write the factors like here? 4p and 4q. Yes, I must. And in this factorization, I should get 60 times p and 60, negative 60 times p and negative 60 times q. How can I get negative 60 times p? There should be a negative 15 here, right? And how can I get negative 60q here? There should be on the other, 4q is here. When I multiply, to be able to get negative 60q, there should be a negative 15 in the first binomial. And when I expand this, look, it is 4p times 4q, that is 16pq, minus 60 p and q, and negative 15 times negative 15 plus 15 squared, right? If I add, to be able to get these factors, if I add 15 squared, I have to add 15 squared to the other side of the equation. So this is what I did here. 4p minus 15, 4q minus 15 is equal to 16 squared and 15 squared, which is 481. And after that, I checked, since I'm supposed to solve the problem in the set of integers, I checked integer solutions of 481. The integer factors of 481, positive 1, negative 1, positive 481, negative 481, positive negative 13, and positive negative 37. Here, for the ordered pair 4p minus 15 and 4q minus 15, we have these cases. We have more cases, but I forgot to check them all. This part is your homework. You're going to check the negative cases at home later, after we finish. And the ordered pair p and q, if 4p minus 15 and 4q minus 15, these are possible cases for p and q. 4 and 124, 124, 4, 7, 13, and 13, 7 are the possible cases for p and q, for the ordered pair p and q. And when you go back, when you check in this system, when you check the ordered pairs p and q, only 13 and 7 will satisfy the equation. Let's check it. Let's see it once again. We know that p and q are the variables, are the coefficients of the equation, but also roots of the equation. So when we write the equation, we get this. From here, the roots are 13 and 7. As you see, p and q, when p is 13 and q is 7, the equation will be satisfied. So this is the solution. Philip, is factorization part clear now? Let me show it once again. Maybe you're copying. Is it clear now? Okay. Can I show you the next problem then? Next problem. Okay. No. Next problem is a nice look at the solution. Next problem is a system problem. Solve the system in the set of real numbers. Solve the system in the set of real numbers. The system, first equation is xy, yz, xz is 23. Second one is x squared plus y squared is z squared. And the third one is z minus x times z minus y is 2. Yes, good luck. Try to get something in this system, guys. Then together we will solve the problem. You have 2 minutes to try to solve this exercise. What do you think? If it's a nice problem, that means it's easy, or it is It is a little bit difficult. Strumitsa kids can help you. They know my nice questions. 2 minutes. Yeah, 2 minutes is not enough, of course, to solve the problem, but at least you can get something useful to solve the problem. Okay, Vlatko, you have 3 minutes. By the way, where is Lesh? Dimitar Leshev, where are you? He is here. Okay. Quiet boy. Bravo, Vlatko. You see, before the end of 2 minutes, you got something useful. Spase, Dimitar Leshev is a good boy. He won't leave. You overslept yesterday. He did not. Okay, let's talk about the question now. Vlatko got that x plus y squared is 25, which means that x plus y is positive or negative 5. It's a very useful equation that we can use to solve the system. And let's get something else for z, then you will be able to solve the question. By using third one, you can get something for z. Christina says x times y is minus 2 and x plus y is 5 gives one solution. Yes. Christina, can you please use that information in the third equation to get z? Because you got x plus y and x times y. Z is plus minus 5, yes. Wait. No. For z, I got 3, 7, and -3, -7. I think you have a calculation mistake for z. And be careful, x plus y is not only 5. X plus y can be plus or minus 5. Because you said x plus y squared is 25. There are two cases, don't forget. One is positive, one is negative. So let's start to solve the problem, guys. No time, break time is coming. So in the third equation, I started with the third equation. Z squared, when we multiply them, we can write the equation in this form. Z squared plus xy minus z times x plus y is equal to 2. And from the second one, we know that z squared is equal to x plus x squared plus y squared. And from the first one, look, if you multiply them, it will be z times x and minus z times x and minus z times y. If you use the first equation, you can write this minus z times x plus y in this form. X times y minus 23 is equal to 2. So let me simplify this. We will get x plus y squared is equal to x plus y squared, because here we have x squared and y squared, and 2xy gives me x plus y squared is equal to 25. From where minus 23 goes to the other side, it's 25. So x plus y is equal to plus or minus 5. If x plus y is equal to plus or minus 5, from the first one, if we multiply the first one by 2 and add it to the second one, what do we get? Let's see together. If, yeah, better like this. If we multiply the first equation by 2 and add by 2 by the second equation, we will get this: x squared plus y squared plus 2xy and 2yz, 2xz plus z squared and 46. Any problem here? I've multiplied the first equation by 2 and added by the second one. From here we have x plus y squared is equal to, x plus y squared and 2z x plus y is equal to 46z squared. And we know that x plus y is plus or minus 5. I got it from the third equation. If if x plus y is plus minus 5, the simplest form of this equation is going to be z squared plus minus 10z and 21 is equal to 0. Now we have to solve this problem for z. I'll check it for the first case. If x plus y is equal to 5. If x plus y is equal to 5, the equation is going to be z squared minus 10z plus 21, which means that z is 3 or z is 7. When I factorize it, the factors of this quadratic. Z minus 3, Z minus 7, so Z is 3 or Z is 7. And from the first one, from the first row, look, from here, and Z is equal to 3. If I substitute this, I want to show it like that. Yeah, from this equation and Z is equal to 3, I will check for both values of Z. If Z is 3, if Z is 7. So here, in this equation, if I substitute Z and X plus Y, Z squared is 9, right? And XY we don't know. We know Z is 3 and X plus Y is equal to 5 for the first case. So from here, X times Y is going to be 8. What do we know here? We know that X plus Y is equal to 5. Here it is. X plus Y is equal to 5 and X times Y is equal to 8. When you try to solve this system, you will not get any solution. The first system does not have any solution. Let's check it for the second one. If Z is 7, again I will use this equation. Z squared, which is 49 plus XY, minus Z times 7 times X plus Y. It will be XY equals negative 12. Now what do we have? We have another system. X plus Y is equal to 5 and X times Y is equal to negative 12. When you solve this system, the solutions of the quadratic equation will be X is root 73 plus 5 over 2, or 5 minus root 73 plus 2 for X. And if X1 is this, Y1 is going to be 5 minus root 73 over 2. And if X2 is 5 minus root 73, Y2 is going to be root 73 plus 5 over 2. So from here, what did we get? X1 is this, Y1 is this, and Z is 7. And the second case, X, Y, and Z is 7. We got two solutions from the first case, if X plus Y is equal to 5. Now what if X plus Y is equal to minus 5? If X plus Y is equal to minus 5, I'm solving this system, this equation once again. Here. Z squared minus 10Z plus 21. Remember this. If Z is equal to 7. If Z is equal to 7. Oh, no. No, guys. No. I'm not solving the same equation. If X plus Y is equal to minus 5. If Z plus Y is equal to minus 5. The equation with Z, the quadratic equation with Z is going to be in this form. Z squared plus 10Z plus 21 is equal to 0. From here, Z will be minus 3 or Z will be minus 7. So I will check by the same way if Z is minus 3 and X plus Y is minus 5, or if Z is minus 7 and X plus Y is minus 5. From the first one, if Z is equal to minus 3, from the equation again, I will get X plus Y is equal to minus 5 and X times Y is minus 12. When you solve the system, you will get these roots. Here, Z is equal to what? Minus 3, the third one, and Z is equal to minus 3. And if you try to solve the equation for Z is minus 7 and X plus Y is minus 5, you will get this system. X plus Y is equal to negative 5 and X times Y is 8. From here, from the last system, you won't get any solution. So how many possible solutions we have for this system? The first one, the second one, the third one, the fourth one. From where did I get first and second solutions? If X plus Y is 5 and Z is 3 or 7. And from where did I get these two solutions? Third and fourth one. if x plus y is minus 5 and z is minus 3, and if xy is minus 5 and z is negative 7. Show all the steps here, so if you want I can show the solution from the beginning once again. What did we do? Let's remember together, then we will have a break time. From the third equation we got z squared plus xy minus z times x plus y is equal to 2. We used the second equation to write z squared is equal to x squared plus y squared, and from the first one we got minus zx and minus zy is equal to xy minus 23. When I simplify this equation, I got x plus y squared is equal to 25, which means that x plus y is plus or minus 5. This is the first one I got. X plus y is plus or minus 5. After that, we multiply the first equation by 2 and add to the second one. What did I get when I do this? I got x squared plus y squared plus 2xy, 2yz, 2xz equals 46 plus z squared. Here, first three terms is square of a binomial x plus y squared, and the fourth and fifth terms we can write them in this form: 2z times x plus y is equal to 46 plus z squared. So we got an equation in terms of x plus y and z. Don't you remember we got a solution for x plus y. X plus y is plus or minus 5. So here, if I substitute plus or minus 5 for x plus y, the equation will be, the simplest form of the equation will be z squared plus minus 10z and 21 is equal to 0. Now we solve the system in two cases. First case, if x plus y is equal to 5, and the second case, if x plus y is equal to minus 5. What am I solving if x plus y is equal to 5? I'm solving this quadratic equation, z. So if x plus y is 5, z squared minus 10z plus 21, the roots of this quadratic will be 3 and 7. So I need to check these two. X plus y is 5 and z is 3, and x plus y is 5 and z is 7. When we check the first one, x plus y is 5 and z is 3, we got x times y is equal to 8. Look, I can write a system with x and y. X plus y is 5 and x times y is 8. So when I try to find the solutions of this system, I will fail. There is no solution from the first case. From the second case, if x plus y is equal to 5 and z is equal to 7, when I write the when I substitute these two, x plus y is 5 and z is 7 in the equation, I got this: 49 plus xy minus 35 is equal to 2. From here, x times y is negative 12. So I'm able to write a system with x and y. X plus y is 5 and x times y is negative 12. When you solve this system, you will get x1 is root 73 plus 5 over 2, y1 is 5 minus root 73 over 2, and don't forget z is 7 for this case. So this is the first solution. The second solution of the problem, x2 is 5 minus root 73 over 2, y2 is root 73 plus 5 over 2, and z is 7. From the second case, by the same way, x plus y is equal to minus 5, we substitute in the equation and we got z squared plus 10z plus 21 is 0. So z is negative or negative 3 or negative 7. From the first one, if x plus y is minus 5 and z is minus 3, we got this system. X plus y is minus 5 and x times y is minus 12. When you solve it, you will get x3, y3, and z is minus 3. This is the third solution. And the second solution of the problem will be, second solution of the second case, which means that the fourth root, x4 will be minus root 73 plus 5 over 2, and y4 will be root 73 minus 5 over 2, and z is minus 3. When you check x plus y is minus 5 and z is minus 7, there won't be any solution for the system. So we have only 4 solutions for the given problem, for the given system. I hope it is clear. Is it? Is it clear, guys? Do you have any question? Guys, who got it? Christina got it. Monica got it. Philip. Spase. Damian. Sandra. Okay. So we can have a break. At 11 we will start again. See you guys. At 11 and 10. Okay, let's start at 11 and 10. Go and have your breakfast. Enjoy it.